In this video, we're going to look at some general linear equations and interpret what they look like, what it means to vary parameters, and look at all possible forms that these equations can take. So one of the questions that I left on the notes for you to sort of think about before the video is, what does this equation x plus y equals a look like for various values of a? Now one way to sort of see is just pick some values, right? Let's say a equals 1. Then x plus y equals 1 is going to look like this point, which is 1, 0, and this point, which is 0, 1, and a line through them. If a is 2, then this is x plus y equals 2. You would still have the same slope, except now it's going to go through different pair of points. If a is 3, then it's the same slope. It only goes through a different pair of points. So in some sense, what's happening here is, if I were to plot all of these on one single graph, right, then they would look like a bunch of parallel lines that shift upwards and upwards. Okay? So as you increase the value of a, you go from the blue to the yellow to the red line. Okay, so this is what it means when you have a question like, or you're thinking about, how does this change, or how does this vary if I pick different values for a parameter? As you change the value of the parameter, the line moves from being blue to yellow to being red. Now similarly, the question can be asked, what does y equals mx look like for various values of m? So in this case, first of all, there is no intercept, right? So let's do some scenarios again. If m is 1, I want a different color. If m is 1, then this is y equals x, and that's just that straight line. If m is 2, then this is 2x, which means it becomes a steeper line. When m is 3, it becomes 3x, which is an even steeper line. So in this case, what happens is, oh, I want another color, right there. In this case, as m increases, we have a rotation. So as m increases, the lines begin to rotate. In the previous case, as a increases, the line moves, right, or translates. Now, there is this website which we will be referring to in this course. It's called Desmos, desmos.com/calculator, and you can kind of play around with these graphs and functions and equations here. Of course, you still need to know how to plot them on your own, but this is a very good tool for visualizing. So for example here, first of all, I have x plus y equals a, and a has been set to 1. Now as I vary a, as expected, we just saw that this is what happens, right? The line moves parallelly, but it moves up and down. So that if you make an animation of it, that's what it's going to look like. Now, whereas in the second case, which is y equals mx, when m is 1, and then if I change m, as we observed, it rotates. So these are two fundamental general equations, one of which causes it to move left, like up and down, and the other causes it to rotate. Okay, so you can see that at some point the purple line does become parallel to the red line, and so on, which is going to be our next topic of discussion, which is solve the system of equation, but it's a general system of equation, meaning a and m are some numbers that you are not given beforehand. So let's see, the coefficients of y are already the same, so all I have to do is subtract. Oh, never mind. Let's do one short in the second one, the coefficient of x is m, so it's actually mx minus y equals 0. So here I don't even have to subtract, I can just add. When I add, the y cancels out, right? So all I have to do is add. When I add, I get x times 1 plus m equals a. And I know how to solve for this. I divide by 1 plus m. So I end up with x equals a over m plus 1. I still need to solve for y, but recall that what is y? Y is m times x. So it's am over a plus 1, which means that my solution is a over m plus 1 and am over m plus 1. Now comes the second part of this question, which is you have to be a little careful. Does this solution always exist? And the answer is no. Why? Because not if m equals -1. Why? You should be able to answer that question. It's because the denominator becomes 0, which makes it a division by 0. So what really happens when m equals 1? Graphically, if m equals -1, then y equals -x. And that equation can be written as x plus y equals 0, which means it's parallel to x plus y equals a, right? That's why there is no solution there. You can also look at it graphically. So we said when m is -1, right there, right? When a is 0, there's going to be infinitely many solutions. But for any other value of a, they're going to be parallel. So there's going to be no solution. So this is an example of how you can interpret a general equation and algebraically find the solution, and also be able to say when the solution exists and when it does not exist, as well as once you do that, you can go and play around over here and notice that, see, for all other cases, even whether you move one way or the other, you always end up with one point of intersection, which means you always end up with one solution. Okay, that's it for this video, wherein you look at systems of general equation and interpret the result.